Let me see.
Going recursively. Yeah, now it's
right. Okay. So right. So let's see. So how much did you see?
So I went through the initial bootstrap, like CPS class where everything, the whole thing happens, and I went over the CPF workflow execution class mostly, that, and associated class like thread groups and what's the other thing.
Okay.
Yeah, I don't trigger, but I just kept going from the very beginning where this thing is triggered to this whole workflow sort of thing. And kind of got a general idea about how this different, like, when you probably do a checkpoint and from where the build comes up, how from persistence all the way it goes to runnable and then suspended on all those things. So I have kind of general idea, I would say, how this thing works.
Okay. So maybe just do some quick recap and
yeah, I think that would be great, and especially some of the things like intricacies such as a step context parameter to inject the values from the context into the abstract step input subclass. Okay. But then how do I know which classes, like task listener, I can see that this is injectable kind of class available, but what are the other things that would be available when I'm kind of implementing this?
Okay. So so in your context, I guess the first thing is you don't really care about how the jobs are organized and how they run with calling with flow execution. So I think the most important part, I think, is the first how this stuff is actually get run. So maybe I should reduce the screen resolution. Maybe I should. So the much of the program, so I guess the main program state is in CPS group class.
Right.
So this is the sort of like, if you think of the virtual machine, like I almost think of this as like a mini virtual machine that's running inside, because this is like almost an interpreter for the Groovy execution. So this mini virtual machine has like a multiple threads of execution. So the easiest way to think of it is because when you have a parallel task, like you have to have 2 points of execution, right? So each thread is actually mostly only the interesting bit is continuable.
Groovy kind of.
Yeah, so this actually goes into one of the dependency library, and the general idea is that you'd be able to basically step execute the program. And then without actually having the call stack as the real call stack. So I think where you do this, I think it's something like here, the run.
Run 0,
Right. So at the pause point, or what I call it the save point, it's like it's almost like this program is hit at the breakpoint, so like it's executed at a certain line of the code, and then the function or so on. And then when you call the run, you do like execute until it gets paused at the next point. Or actually, saying it's a breakpoint is actually not accurate, because it's only get paused at the suspend point. So when the program inside CPS would call the suspend method, and then it can take a value here, and then that would bring this thread, this continuable, to this pause state. So from the CPS transform program's point of view, suspend is like a regular magic function. It's like a function that takes argument and then it returns something. But while the suspend is getting called, it's sort of like that's when it pauses. And then so from the caller's point of view, it gets so that's when the run would return, and by getting the value. And then at some later point, maybe in another JVM session, it calls another method, run method one more time, and then that value that it gets passed, the frozen CPS program would start executing by returning from this method.
So I got a little confused. So in this sense, so let's say I have my Groovy script, right? And let's say it does,
so like
it does things like, let's say print foo and suspend. So if println foo needs to be executed, right? So each of these lines, so what are the things that gets into, let's say, a thread? Like each line goes into each thread as a separate thread of execution?
So the thread, the CPS thread, or the single continuable object, is almost like what you think of as a normal thread.
Okay.
So you think of like a mentally picture CPU that's executing first this and then next this and then something else. So that's still one thread.
So it's still one thread. Yeah. So what does distinguishes from one thread to another?
Right. So like a multiple threads case is it needs some like a different primitive, but so the one that we have is parallel. So if you have like a parallel task that has one closure that's printing echo and another closure that's printing bar, then at this point, like it will actually you can mentally picture two logical CPU executing left and right. So that's when you start getting two threads.
I see. Okay. So otherwise, mostly it is one single thread of execution, one after another it keeps going. Yeah. Okay. And how? So when you said suspend, so first time we call run. First it suspends, and return of the suspend is called again to invoke run.
Right. So let's say this is a CPS transform program, right? In its entirety, and then the way this feature. So you first get the continuable objects by basically compiling this script.
Correct.
Files, and then first time you run, you start calling null. And then at this point you can think of this continuable as representing a program before executing any of this. So the first argument is ignored because there's really nothing that you can pass anything into. But so when this happens, the CPS should start running and it executes print line 2. But this is a synchronous method call, right?
Yeah.
And then it calls me to suspend 1, and then that's when it pauses. And then this X, from the caller's point of view, this X run will return.
Okay.
And then, so yes, and then now, at some later point, if we call X run again, let's say it's something else. And then from the CPS transform program's view, the suspend call will return.
So what is the meaning of this suspend in the sense? I mean, I was picturing suspend more like there's execution going on, it kind of paused, meaning it is when it continues back, it continues from where it left off, right?
Correct.
But here it is more like you have control. You may have different scripts, and it's more like you have this whole execution. Maybe pipeline may not be the right word, but it's like the whole execution pipeline available to you, and you give it something, run, it comes back, and it's suspend, meaning it is keeping hold of the thread on which to execute, and you again call run to use the same thread, basically resume and run something else.
Right, but except remember these two threads, I wrote this as if there are two executions, but these are actually still run by single Java thread. That's the magic part.
Yeah, and that's what I think I understood with the suspend, that it's a one execution thread where you keep calling run on that script and it keep running, and after it finishes, it's suspend. It doesn't release all the resources.
Right, yeah. So it remembers all the call stack and local variable values and so on.
Right. So that all the script, every sentence that or every statement that is executed, it has the same context to. Okay.
Yeah. So the way we use this in Jenkins is, let's say, in the workflow is that so let's say we want to execute a fork of a long-running shell, like a test process. So internally, what it would do is it would fork off this process, and then it calls suspend, and then let the code, and then go do whatever else, and then later when we decide that the result is in, and then it call run, which is another program stuff. Okay. So that's the general flow of execution. So that's behind the scene what's going on, and then the step is the sort of what you see as all these functions in the workflow. So the workflow you might have seen you have something like so let's start with the simple one, right? So if you do that, if somebody has a program like that, then So this step, we look for the step descriptor, which declare the function name here. So we try to match that up. So the echo step, I think, has the echo as a function name. So that's the ABC along its chosen.
That's what goes as a DS.
Right, and then so the CPS, Groovy CPS engine will instantiate the new echo step class, and then it performs these, well, parameter injections.
Okay.
So the one, so these functions in general could take, so the way this parameter binding works is like basically modeled after Java notations. So where you would say, the general case is the name, value, and so on. So this should map to, if you for this to work, you have to have a constructor that name, like,
And I saw in the browsing through the code that with the echo, I can also have the last parameter as a closure object sort of thing. That body that you can explore.
Right. Yes. So this is, well, yes. So that's true. But let's start with the basic form, which is this. So the parameter names are matched against the argument names and so on. And then the reason I mentioned about the Java notation is that a special form, if you have just the value, one value, then it sort of gets bound to like a parameter name value.
If it's only one parameter.
Yeah. So this is just like in Java notation, when you only have one parameter, you need the name.
Right.
So that's that. And then as you noted, the closure gets treated a bit differently, and then that's why I first want to do this echo. So it does instantiation, and then you can get this parameter injected either through the constructor if it's mandatory, or you could also request the injection through the setter. So I don't know what echo would probably have anything, but if you have any argument, then you could then that could also get injected.
Injected with the same calling mechanism, comma separated.
Yeah. So if this, in this case, I guess if you have this is becoming a bit contrived, but if you do that, then the constructor gets called this value. Yeah. So there's that, and then what you notice is this context parameters. So let's see, what was the design thinking behind this? I think originally this sort of, the way I think of this is almost like as a current directory. Like there are certain things sort of like that carries implicitly through the execution. Like say in a shell script, there's notion of current directory. You could change those, but there's like always one that's running behind. And then so this is like a bit of a generalization of that. So there's a number of these guys, and then you can see those in here, step context get. Okay. So that's where I think you can see the actual documentation of what are
all the things that
are currently supported. So the equivalent of current directory is here, like in Jenkins. This notion.
You have run also available, the current building.
Yeah, for in most steps at least. Well, so yes, if you run this, if CPS flow execution runs as a part of in the workflow build, then there's this implicit access to the run object that you can get. Yeah. And similarly, the access to like where you want to produce the console output. I think these are probably the main ones that you care about. Right. Yes. So those are, I guess, the general guys. So you could request injection of these things, or you could just request. So these like injection stuff is just really just a sugar. It's actually, so perhaps that's what I should have talked about. So now we instantiate the step. So that comes from the plugin, right? The other plugins. And then from the CPS flow execution engine, you get the access to the step context. Yeah. And then, so that's like the API that you as a step implementation can call to interact with the rest of the CPS engine. Well, actually, or any flow execution for that matter. But, so that means So all these things that you're doing here is just providing a bit of convenience so that you don't have to manually go look them up. And then, so once those injections are done, like your instance is set up, so now you actually get executed through this do start method. And then, so the simplest one to be easy, so there are like two ways to get execution going. One is actually the synchronous, and the other is asynchronous. The latter is harder, so let's talk about the former one. So the synchronous execution is like you do everything inside the start method, and when you return, you're done. Right? So there's no this long running magic anywhere. But so like the echo would be the trivial one. So here you see that it's just echoing the flow. And then you'd be calling back to the context, saying this step has completed successfully, but it's synchronous. So by now you already know the result. Mm-hmm. And then to sort of and then you also tell the same thing by returning to from here. So that's saying it has executed synchronously. Mm-hmm. So some of these. Yeah, so the echo would work that way, so that's the easiest one. Now, the more interesting one is actually the one that runs asynchronously. Right, so let's see, what are the good simple examples for async? I think the input...
Sorry, go ahead.
Yeah, I think the input is probably a relatively simple implementation of asynchronous execution. So this input step is like when you get to a point in workflow, it waits for a human to come in and press a button. And so from the CPS program's point of view, it's an asynchronous step in that, okay, when it hits that input call, you pause for a long time until the okay is coming, and then it would start running again. So this is a reasonably complicated implementation, but the real logic is really just here. So eventually, the only thing we need to do is to run asynchronously. Is first you have to hold on to the context for the duration of your entire long-running asynchronous process, and you can even serialize this into other form when we need it. Because say if you want to come back to this step context after the JVM would restart, you have to somehow persist that, right? So the context should support persistence. And then here, all we do is basically return false here, which means I think it's documented in the it's actually much of the documentation is actually in the start method. I hope, yeah. So that's right. So basically saying, okay, now I started to execute it asynchronously. So I'll let you know, and as a step implementation, I'll let step context know when it's done. And then the way you let them know is by calling either on success, if the execution of step has successfully completed, or the on failure, I think, on failure, reporting that there was an exception. So it actually extends from future callback that defines these two guys. So what does it mean for the pause? So I think for the pause, what it does is it just so it remembers this basically like a context object for.
So I'm getting him a sandwich because we have a meeting starting. Do you want one, or do you just want to go back out?
I'll go back and get it.
All right, that's Steve making camera appearance in the recording. So what we are doing here is just basically just holding on to the context, right? So here we want to do is when the people actually press a button, we will have next call the on start. So we do that by basically attaching this. Instead of because the input step actually has a lot more than just the context. Like I want to remember what message to put in the UI. Sometimes you can ask people to fill in more details. Instead of just having a button, you could ask people to type in the text or upload a file or that sort of thing. So there's a lot more around context line, just like keeping the entire input step object itself, but that includes a reference to the context. So I'm doing that, and then so I'm putting that object as an action into the run object. So
this is the same action that Jenkins knows, or is this action metaphor is different.
So well, yes, okay. So the action is a somewhat confusing notion in Jenkins, but if you're curious, you have a thing. And there's a wiki in the page that describes about this like whole action thinking. So if you haven't seen it, that's highly recommended. So what we do, so basically it's just like you can think of a random bag of properties that's associated with run. And then the run is obviously persisted, and then so are our actions. So when we add some stuff to the action, it basically just automatically gets persisted. So that's why we are doing that.
No, I use action in that build environment plugin.
Okay, yeah.
So I use those actions. So I have seen that, how to attach and
that's good.
And get Jenkins work.
Right. So at this point, like you're returning false, so the polar would assume that like you want to false. Right? So like it brings the whole workflow into codable state, and then write them out to the disk and all that, do all the stuff that you don't probably, hopefully it doesn't have to care about until it gets buggy. And then at some later point, you'd come. So like let's imagine then the JVM would go shut down, right? And then like Jenkins would come back up, and then your action our action gets deserialized, including the reference to the input step, including the reference to the context. So like everything you need is basically back in memory. And then later, when somebody presses a button, it actually comes here.
Okay,
and then
this is where it kind of resumes, right?
Yes. So yeah, and then so here you see that it's calling back the context of success. So that's not telling anything that now I have a result for you.
Yes. Okay.
And then that's how it's possible. Okay, so it's basically removing once the outcome is determined. You're not going to be keeping them around.
The whole thing happens in kind of transactional sort of block in that sense, like atomic operation.
So good question. So I think there's actually there is no transaction that cuts across all these different serializations. So there's technically if the JVM would shut down, I think there's a brief window of vulnerability between this and the point in which the workflow would actually start executing.
Right.
So
if I picture the synchronous way, I think this should be just fine. But I was more thinking about I have parallel threads, right? Mm-hmm. Threads of execution, and each one could have different issues going on.
Yeah.
And at any point in time, we get into this dirty sort of a state. Dirty state by I mean maybe some threads. Maybe JVM started running out of memory or some of those kind of situations, and so let's say we had 3 parallel threads. Couple of them could persist their state on the disk. The whole action thing is persisted. So when JVM is restarted, everything there, but third one was kind of dropped out. It couldn't get written, on the disk. So when you restart the JVM, those first 2 executions will come up nicely.
Right.
But the third one is like it is restarting from the beginning. Assuming that it's truly like kind of a pure side effect free kind of execution, then I don't see any issue. But if there is some certain dependency, these executions look into each other, things could get messy. So.
Yeah, so I guess so the out of memory station is a bit tricky. So yeah, I suspect there are some interesting failure modes that we haven't really thought about. So that's probably true. Although I don't think. I think this window of vulnerability is hopefully small enough that I think it's okay.
Yeah.
So here, for example, like.
But or maybe you already took care of it. So I was kind of thinking yesterday evening that you have these multiple threads, and somehow I kind of inferred by looking at the code that maybe when this thread group is kind of either deserializing or setting everything up, it's not like everything just gets started. I thought, or maybe I inferred that it first kind of make sure that the write to disk happens atomically for all of them, and then only resume for everything else. It's like everything in suspended state. Did I misunderstand?
Well, so for example, here, in the context on success, the idea is because now the result is available, that should be persisted before we even try to rerun them.
The persistence at different level, not initial.
It's actually, we don't do that today, but we have to do that. But then that write out of the state and then this removing whatever is actually done, it's still the two different writes. So it's possible that like one gets done, but the other isn't.
I think initial state is easier to handle than when anything can happen can finish execution at any point in time. Okay.
Yeah, but I think we can make it work well enough that I'm not too worried about it.
Yeah. No, I'm just kind of my curiosity.
Right. Okay. Yeah. So that's the like a general the flow of asynchronous execution. So the idea is so your start method gets called, you return false, and then from then on you have to do your own bookkeeping. And then when things is done, you'll call back the context and then tell the engine that you're done. So if you look at other implementations, they basically all do the same thing. So in this case, the bookkeeping for the step is through the action, but some of the other ones do a bit more complex things like which one? Durable task step. I think he didn't extend one. So let's say, durable task step. So this is the one that's calling into shell script. Mm-hmm. And then here, I think it's got its own bookkeeping logic that's involved. Let's see the start method here. So it's calling start method here. And then what is it doing? So it's trying to remember which node it's running on, and then remember basically, so this is where it starts remembering. So for every the bookkeeping happens by having this looks like a single massive map, a synchronized map that keeps track of these running tasks. So I guess this keeps up all the processes that popped off everywhere in Jenkins. And then there's, I think, the separate, like a watch thread that's periodically checking if any of these guys are completed. And if they are done, I guess it's sort of reporting that success. Reporting success or failure, so now it's starting to be executed. Right. So in case of, the one that you'd be looking for, so what you'd be doing is triggering a build, right? So in the start, I guess you'd schedule a build, and I think kind of have to hold on to, you get back the future objects, I think kind of have to hold on to that, and then I suppose, depending on that outcome, you then call back the context.
Right. How about the listener? I mean, do I need to report back the build status to the listener, or pass that listener all the way to the build object?
Well, I think, that's actually interesting. But I think as a starting point, it's probably sufficient to just say, like, okay, I'm triggering this now. And then it started building. So I think of three major state change. One is that you scheduled something, and then it started running. And then at that point you have actual a difference to the build number and so on. So you're I think going to capture those, and maybe so if you can report that to prove that you get this info. And then the third point is when it's actually done. So I think if you just produce 3 lines of output for now, I think that's sufficient.
And now. So before I get to that question, so in this, right? Yeah. So can you go a little bit back up the bookkeeping part, right? So of course, I would return like this task, on the start it returns false, right? And then it schedules something, and then it returns, right? Returns false. Now in the background, so every step implementation, especially the async ones, right, needs to basically do some bookkeeping of its own.
Yeah.
And the way it will be doing. So is there any infrastructure built inside abstract step implement?
Yeah. So
because it's like mostly, in a thread you are basically trying to see that whether this, and the feature could be different for different,
Yeah. Yes, I think, right. I think you're right, and I think that's the kind. So we haven't really talked about those stuff, and I think partly that's the kind of thing I think we need to think about it. Although in this case of triggering jobs, it's actually you don't really need to build up your own infrastructure because I think all you have to do is to add an action, add your action when you submit the job. And then you basically have to monitor every build completion and build start event, which you can do with run this run. And then so, if you discover that the build has started that has your marker action on it, then now you know that, okay, like the one that I care about is going.
Yeah.
So I think that's how I do it. So you can basically piggyback on existing stuff.
Stuff. Okay.
So you'd have to guess the
yeah. Okay. And in terms of triggering a build, right? So how do I go about? I mean, from the Jenkins plugin perspective, it is like build is executed by Jenkins master somehow, right? I mean, user clicks build now and it happens, right? And in case of a step implementation, how a build is triggered? I mean, that's the most basic question.
Okay, all right. So that's all right. That's a easy one. So you got it. So there's a queue class and then the one function. So I think what you do. How do you do this? Actually, so I think the way I normally do it is in the one of these project methods. There's a schedule.
Okay.
I think this is the guy. So let's see how does that call into which you actually in turn execute into the there's a very difficult stuff here. But eventually it comes here. Okay. But I think if you just I probably just call the this Q abstract project schedule build.
Okay.
But then it's not. Why is that abstract project? So then workflow is not an abstract project. So in a way this is a bit misleading. So
workflow is not an abstract project.
Yeah.
What is it then?
So it's one of these base class. I think it extends directly from job.
Okay, it extends directly from job.
Yeah.
Okay.
I thought there was like an interface or something. Maybe this is it. Wow. This is starting to look.
As a project call method on that.
Then there's no one state. Well, all right. Why don't you just start with abstract project? I think it's like
I'll look deeper and figure it out.
Yeah. So perhaps some refactoring needs to be done before. It's also possible.
Yeah, I'll make some progress and the reason I asked is that I thought maybe in 2 seconds you will tell.
Yeah, sure.
Through the code,
yeah.
So.
Yeah.
But I think abstract project is good to start, and the interface wise, it would be more like it should. I can come up with anything, but it would be more like a steps dot. I don't know. Build, and you give just the project name.
Yeah.
So in terms of Jenkins organization, right? The thing is that as a user, I may like to invoke a project that is inside a folder, for example, right?
Yeah.
So is there a hierarchy we need to come up with, or we should have a concrete class?
So you can use the get item by name, get item by what was it? Resolve. What's the name of the method?
Yeah, I was looking at the build trigger plugin to see how it basically gets the project, and it uses one of those methods you are saying, get item by.
Yeah, I think so get item, and then so the trick is you want to pass in. I think the flavor you want to use is the one that takes the. All right, so the first is string name. That's the one that you get that string, and then you want to resolve. It's like you get the context of the parameter, which sort of decides. Okay, like if you are already in a folder. All right, so I think this one. So because you run inside run, right? So that's when you resolve the job name. That's like your current job is basically the point of reference. So you want what you want. So you pass in the string as is, and then in the second context parameter you pass in the workflow job that you're currently running. And then third argument is the expected type. So in your case, it's abstract project, and then you can basically get abstract from it. So
Perfect.
Yeah. So I think that's the basic building block. And actually, the one more thing, the closure. I didn't talk about that because that's the one of the more complex part. So the body closure is not explicitly. So in Groovy, like the closure is a closure object that you could call, yes, right? Yes. But in here, so I think Jesse didn't. I think if I remember correctly, Jesse felt like a abstraction like that would be leaking too much into certain implementation of flow execution. But anyway, so the way it's done now is, if you want, so if your function takes this implicit closure argument, like I think the retry is a good example. So like if you say something like that, then the step context is actually take care of this unloads. It's like a body closure especially differently, and then you don't really get this as a difference as a parameter. So except instead you can call, you can ask the context to execute that closure at the timing of the choosing by calling this invoke body later method.
Yeah, I mean, I was, kind of thinking.
Yeah, you can find.
I was thinking about something like this, where, I don't know, to project, and I was thinking in terms of, closure. I'll just give a Ruby syntax.
I mean, for the build function, maybe I don't think there is any need for having closure.
Yeah, no, this is just for my understanding.
Okay.
I don't really think this use case is something like that. So that build project does something, but maybe as an outcome of this build, what I want to do is I don't know, let's say X. And in this, maybe I want to build steps or maybe using this. If X dot success, I want to maybe do another build or maybe
Well, I think you should just return the result. I mean, the way I think you do it, return the build object as a return value.
Yeah.
From that build.
Yeah. So this X, I don't know what this X could be, but this is the X that this steps implementation of build basically could, call this yield on this closure and give this value and let this body deal with that, and do something else.
Yeah, but I don't think
it's a very basic case I'm saying, but maybe it doesn't apply to build. I just took it as an example. Okay. But in general, is this something like this supported?
Yeah. So I think the retry is basically what that is.
Yeah.
Actually, yes. So the way this would work is it tries to execute the body closure a number of times and then update the times that's specified here.
Right. But what if this retry lets you yield on, I don't know, certain object,
yeah, so it
that kind of closure.
I see. So yes, so this is actually not currently supported.
Yeah, okay.
Yeah, so we need to fix this, and we need to fix that. But
no, this is fine. I think as long as we are going in that direction, this will be very powerful, and we can write very terse script to do,
yeah, but but in terms of what exists, I wanted to describe was so as a step implementation, you can ask the body closure to be evaluated, but that happens asynchronously. So that's what this like a clumsy method name is trying to tell you. So when you call it, it will return immediately, and then the body will evaluate at some later point, and when that happens, you get this callback invoked. So the future callback is the one that has its own success and failure. So you could, at that point, you decide what to do.
So this is so this is something that needs to be handled via your kind of bookkeeping, wherever you're doing, like,
Well,
invoke body letter is executed right then and there, or it is executed at certain, because you need to yield at certain point in time, right? But if it is all asynchrony, I mean, I would like to yield to the closure body at certain point in time where it makes sense for my implementation. So when does invoke body letter is called in kind of?
So let's look at the retry step, right? So that's like a good simple example here. So I mentioned how it works.
Yes.
So what it would do is in the do start method, it will just immediately schedule the execution of the body, and then so this will return even before the actual body evaluation happens. Then we just tell report back that okay, we are running asynchronously. Because I guess the one way to think of it is because this body closure will itself contains some asynchronous execution, so naturally the retry step as a whole cannot execute. So, and then so the CPS. So at that point, they quote it back to the CPS engine. And so this doesn't even do any bookkeeping because the contract is that your callback gets executed. It's just that you have to be serializable because. Because while that's executing here, the whole thing could go back to disk and so on. But eventually, like either successfully or unsuccessfully, the body would complete. Right? So if the body would complete successfully, then the retry as a whole is good. So I just call back into the context. This context came from here. So I'm just holding on to that. If it's a failure, then what we're gonna do is like well, reduce the retry count, and if we are still retrying, then we call one more time for the invoke body later to evaluate that stuff. And then if we run out of the retry count, then we call back saying, okay, we have failed. So
the basic pieces are there. This can evolve. Yeah, this is great.
So I need to talk to Jesse about how the right way to surface this kind of body argument. Part of the challenge, I think, so the part of the design is the reason we kind of have to go through these scripts is because we didn't want the CPS execution to be the only implementation for it. And then so Jesse has, for example, another total implementation of the flow that's based on like what he described as a state machine, like a node and entities between them. And then in his context, this like an argument to the body does not make sense. And so it had to be. So I don't know, but on the Groovy context, we clearly want one. So, so I think we have to work out something. But that's okay. We can fix those better. So that's just a task to be done.
So what else? In terms of the project organization, do I just create another like a step module and add to the workflow, or just add in one of those?
I think you can just add it in the basic steps because the triggering job seems like a basic.
Very basic stuff.
Yeah, and then it only depends on the core. So it's only when you later tackle more complex steps.
A group of steps that makes sense to go together.
Yeah, or the one that depends on some plugin, let's say.
Yeah.
And then I think those are the ones that we want to split into separate.
No, this is fine. I just wanted to know where to put this. Add into this. I think they have pretty good idea. And the pickle comes into picture only during marshalling, mostly on marshalling, right?
Yeah. So for that, I think let's do that in another time. Yes. So I don't think you have to worry about that just yet.
Oh no, that was more of a how stuff works.
So all right. So I'll stop recording.